So we are going to do this. Ready? This will be marked off tomorrow. This will be marked off tomorrow. This will be marked off on Monday. Is that right so far? So what I want to do is I want to give you, I have a pack here of stuff, and I feel that this pack of stuff is going to go pretty well. And I want this, oh, I do move this test to Friday. Most of you are going to cry yourself to sleep by now. But section 3.1 is going to be a really short lecture, so that'll be, I'll do that tomorrow, as well as some more of this reviewing. And then section 3.1 will be what? We'll be due on Monday as well. All right, so this sheet that's coming your way, if I didn't hand enough to your row, I apologize. Or if I gave your row too many, please bring it on up, and I apologize for my miscounting. Just because I teach math doesn't mean that single digits make sense to me. All right. All right, and then, so let's see, other things. So announcements. So tomorrow, I will check this off. Tomorrow, I will check this off. Monday, I will check this one off. Okay? Yes? More, I tell you, coming back to you. One more as well. Jeez. 2 rows now. And then, one more as well? I was like, holy cow. 3.1, I will lecture on tomorrow with whatever that assignment will be due on Monday as well. Okay? Does that make sense? Everyone feel good with that? Quality? Hey, what's happening? You here for me or give me a note?
Oh boy.
Hi. Cool. Thanks. Hey. You got it. Ah. Sammy, where are you at?
Oh.
Sam's wallet is in the registrar's office. Does that make sense?
Yeah, it does. I don't have any money in it. That means somebody else.
Not anymore.
Yeah.
If you'd like, quickly run over and get it, or I'll let you go during this period to remind me.
Alright.
But I'm going to forget I gave that to you, so you got it. Yeah. All right, lights, please. Let's talk about this. Okay, so I'm just on this front page. My goal between today and tomorrow is to make you all feel pretty comfortable about this. And so some of you are feeling some anxiety from the proof. Some of you are like, I think I'm getting this. Okay? And again, proofs are a way of thinking. It's a logical progression of events. It really is good for your brain. I promise it's not anything falling out. But let's take a look at problem number 1. And it says that M is the midpoint of PQ. So if you saw something like that, M happens to be the midpoint of it, what is something that you feel that you could say? Yeah. No? Yeah.
One segment PM plus MQ equals one segment P.
Okay, I agree with that. Now, should we state this? We could. This is a segment addition. What's something else we can conclude? Johnny?
PM equals MQ.
Yeah. So these are both excellent things to think about, and they both go hand in hand. I would have went here, more than likely on a 1-step. Okay, but as you're going through as a proof, this might be required as well. How do we know when? I don't know. So sometimes someone might be able to do something in 4, 5, or 6 steps, and sometimes somebody else might take more. Is there something wrong with one person's thinking versus the other? Well, sometimes we want to make fun of them, but not always. Yeah?
Could you say that PM is congruent to MQ?
PM is congruent to MQ. So go to right here right away. I think you could. I feel good about that. So this would just be like a segment addition postulate And this here would just be definition of midpoint. Okay? Which one's the correct one? They're both good. Okay? Now, problem number 2, can I move off? I'm moving off anyhow. Problem number 2, we have a diagram given. So, by investigation, can we determine if A is right in the center? Well, it doesn't look like it. So, if it's not right there in the center, what can we maybe say? Bless you. CA, what? Equals CT. I like that. Could we have this in there? Possibly. I changed color for a reason. Because some of you will go right to this and then realize you have one more step to go to congruence. Some of you can go right to congruence. Who's right? Both. Okay? This is segment addition postulate.
We get a point marked off if we don't do the.
No, I mean, I feel that if you had the red or the red with the tilde, the little wave, I think your both thought processes are right. Cool? Number 3, can I move? Number 3, ray BA bisects angle EBR. Okay, now this might be something where you're like, I have to draw this because I can't see this. I know I have some angle EBR, and then I have something that bisects the angle. And this happens to be BA. Okay? That's what I would visualize what's taking place on this problem. Can some of you visualize it without the drawing? Probably. So what are some things I could say about this diagram that come with it? Yeah.
EBA equals ABR.
Angle EBA is congruent to. Here, I'm going to make this a different color just in case you wanted the equal in there.
ABR.
Equals what?
ABR.
ABR. Why? Yeah, definition of angle bisector. Okay? Some of you might have seen this. And that's the angle addition postulate. Which one's right? I don't know. Do you have to use both? I'm not sure. But you have to be able to have the go-to. Okay? We all right so far? Number 4. So supplementary angles, the automatic go-to is we know the two angles add up to 180 degrees. Agree? So some people might say that angle 4 plus angle 5 equals 180. Or sure, you could put congruent. Or you could say that angle 4 plus angle 7 is equal to 180. Or again, you can put the congruent. So that might be something that you could state. And both of those are definition of supplementary angles. Okay? Is that the correct way to go? I don't know yet. Yeah, what do you got?
I said that angle 5 is supplementary angle 7.
Congruent. I'm with you. So here's a jump that some people might be able to make. And I'm gonna put that on top of it in case you want it. Angle 5 is equal to angle 7, or angle 5 is congruent to angle 7. Okay, that's bad. That yellow you can't see. I'm sorry. Okay, but why? You know?
So it doesn't matter if you say equal or congruent, like you've been talking about earlier.
So in these cases, no. Now, as far as the problem goes, if it started out as congruent, you need to go to the equal to start substituting in. Or if it started out as equal and the conclusion wants it as congruent, take it all the way through as equal and then create it as congruent at the end for definition of congruence. Okay? Yeah.
Would this be the theorem 2.7?
Theorem 2.7. What does Theorem 2.7 say? And I'm looking at these yellow sheets too.
The supplements is the same angle are congruent.
Yes, that's it. So you're saying that's 2.7. That's you have it memorized that way?
Yeah.
Theorem 2.7.
And then 2.8 is complements, right?
Man, I'm proud of you. So Theorem 2.7, I don't have it labeled as 2.7 on here, but it is known as the supplements. I forget what it said. Say that one more time.
2.7 is supplementary and 2.8 is.
But what does it say? Do you remember the verbiage?
Oh, the supplements of the same angle are congruent.
Yeah, the supplements of the same angle are congruent. Okay, that's fantastic. Okay, does this need to have this done to get to that? No. Okay, so sometimes the theorems, the postulates, the definitions, the diagrams are there to give you a little bit of a shortcut. Are you wrong if you started here? Probably not. I mean, you could easily turn this type of problem into to get to that, and that's transitive, right? And then from there, so that's a transitive property right there. And then you could easily say that angle 5 is congruent or equal to angle 7 because of just subtraction. Or you could recognize that this takes you to the same spot. Yeah.
So would you have to get to the in order for it to count for all the points, you can't just leave it as the box answer. You have to move it over to angle 5 is congruent to angle 7.
Well, yes and no. It depends what the proof is asking for. On this particular proof, it just said, what can you conclude? So some people might say, I can conclude this. Is that a wrong conclusion? No, it's definitely a process that's leading to more of a problem. I would imagine this type of problem could have said, prove that angle 5 is congruent to angle 7 with the given information, and there might be a proof that you might have to go through. Or if you saw this right away, well, what if you didn't see this right away? This is still correct thought. So how's your mind going to grab it and make it work? It doesn't matter. Some people are going to take longer on certain things than other people. Is there anything wrong with that person? No. If we all worked at the exact same speed, we're all different a little bit. So make it work how your mind wants to work with it. What else? Are we good so far? All right. Try number 5 and try number 6. I'm going to draw the diagrams up here. But try and see if you can get something going on that. Talk to your neighbor if you need to. Okay. What do you want to say? Go ahead. Perfect. What do you got?
Angle 1 is congruent to angle.
Can you jump to that right away, anybody? Again, this might be this. I think we could, but why can we say that? Yeah. Yeah, it's a definition of perpendicular. Does the diagram help us on this problem? Is the diagram technically part of a given? Absolutely. Yeah.
Can you say angle 1 plus angle 4 equals 180 degrees?
Absolutely. Angle 1 plus angle 4 equals 180 degrees. Okay? And then other things you could go off of this is you could try plugging it in. It really comes down, and this is a segment addition postulate, right? But that's the big key here, and that big key here is going to say that that and that are going to happen. And then other things you can say is angle 1 is equal to 90 degrees, angle 4 is equal to 90 degrees. Can we throw that in there right away? Some of your minds will. Yes.
So for angle 1 equals 90 degrees, would that be definition of perpendicular?
I would go definition of perpendicular, absolutely. Okay. So segment addition postulate could be a part of this. You could go with angle 1 equals 90, angle 4 is 90. Angle 1 is equal or angle 1 is congruent to angle 4. There's a lot of different ways you can get there. Which way is your mind going to grab it? I'm not sure. I don't know until I grade your test, which is moved to Friday. Okay. We feel okay? Let's take a look at the next problem. This one, they just give us a diagram. What's the go-to on the diagram? Two lines intersecting each other. Few things you should think about. Is it a linear pair? Well, there is a linear pair up there, but it's not labeled. Are they vertical angles? In this case, yes. So what can we say about angle 1 and angle 2? Yeah, they're equal or congruent. So angle 2 and angle 4, they might be congruent or it might be equal. Why? Vertical angles. Definitely works. Okay? Where does your mind go? Some people might want to sit there and say, well, I know if I have this, that's going to work, and I know this, that's going to work. Those are linear pairs or supplementary angles. Sometimes the diagram doesn't have enough drawn, so should you add to a diagram? Technically not, because the diagram's trying to direct you a certain way. But this is right away vertical angles, I see it. But this next one, same thing, I have a diagram. I do have vertical angles up there, but this one is a what? It's a linear pair. So angle 1 plus angle 2 equals 180 degrees because it's a linear pair. Now, can I go to supplementary angles as well? Yes. So this can go to this. These can interchange. Linear pair, supplementary can interchange. But supplementary cannot go in for linear pair all the time. And the reason I state that is sometimes you might have a scenario like this, and they'll say those two angles are supplementary. And you're like, oh, they form a linear pair. No, linear pair has to come together. Okay? Don't look at this. These are supplementary angles. These are supplementary angles and linear pair. Notice the difference? Angle dog is a right angle. Go ahead. Yeah, angle DOG equals 90 degrees. Or congruent to 90 degrees. Which way does your mind see it? I don't know. Yeah.
I said that DO is perpendicular to OG.
Ooh.
Can you like make that jump?
Okay. So, yeah, hang on. So, this would have been definition of right angles. But then you said that segment DO is perpendicular to OG. That's not a Q. Could we run there? Could we go there? I think so. I think it's definition of right angles as well. What is a right angle? Two lines that make a 90-degree angle. Two lines that intersect that create a 90-degree angle. Where do we see it? I don't know. I don't know about y'all, but this front page kind of cleared up a few things. Yeah.
Can you also say the definition of perpendicular?
Definition of perpendicular. That might be a stretch. I think I would give you credit for it, but I think in later math classes they might challenge you on that until you'd have to define right angles first, and then I think it really depends on what professor you're on. All right. Take a look at 9, 10, 11, 12. Try and work through those, and I will try them in a sec. Shoot. Okay. Some of you might be able to look at this and see exactly what it means. Some of you might need to sketch a little picture going, I'm not quite sure what this means. I know I have M, I have E, and I have A, and I have meet, and I have T. And they tell me that ME, let's use a different color, ME and AT are congruent. And then they tell us that AT is congruent to ON. And I don't know where ON's at. Meat.
Meat on what?
On potatoes. Alright. So, they tell me that ME is congruent to AT, and then we know that AT is congruent to ON. What's the jump to?
It's equal or congruent to
ME is congruent or equal to, what is it, ON? What property? Transitive, awesome. Okay? That's transitive property. Some might realize that segment ME by our diagram plus EA plus AT is MT. You know, there could be other things. I don't know if I want to go there, but that's the go-to on that one. Yeah.
Wait. Would ME equals ON? Would that be substitution because there's only two?
We have three things were taking place. Ready? So I see where you're getting substitution. I have 1, I have 2, I have 3. Does that make sense? Meet on trans. We'll just move off that.
Hey, we need to address these things, dude.
Okay.
I'm shying away from that.
Oh my goodness, wait, hold on. I just see what life is great, isn't it?
You gotta accept it.
Life is beautiful.
So,
Any of you play field hockey? You ever feel a field hockey ball? My daughter plays for Arapahoe, and she got drilled right here on this bone, right here. Knocked her into next week. I'll tell you what.
she got a nice little concussion going. But I'm holding this field hockey ball, and I'm like just tapping it on this bone right here, thinking, okay, that was like someone's full-on swing, and she caught it right there. I'm like,
Great cat.
that just hurt. You guys want to hear something weird? Anyone play soccer in here?
Oh, dude, that was great.
Couple soccer. So I coached my youngest daughter's soccer team. We've been coaching this team for 6 years. We've snuck our way into competitive, and being that me and two other dads coach them, we don't need to be paid coaches. So we pay a lot less and play the competitive, which I love. It's great. And then parents get mad because they're paying triple what my kids are paying, and we're beating them. So it is what it is. But I have a great understanding of soccer. Of course, I'm going to coach my kids, their teams, because that's awesome. My dad never did. My dad only showed up to two of my football, baseball, soccer, or wrestling matches in my entire life. And he had actually said one thing one time a couple years back that made me proud that he didn't show up, because he did show up to one of my soccer games that I was coaching my daughter, and we're slaughtering a team like 19-0. So what do? At halftime, I start making up rules, and I moved my offense to defense, my defense to offense. And my dad's standing right there, and the girls are, what were they? They were 10 years old at the time. My dad's like, oh, so you're moving the kids that aren't so good up front? I can't get that one back. This is my dad saying this. Thank goodness he never showed up. But needless to say, we had a game this weekend that my dad did show up to. I made him sit on the opposite side of the field because you can't have parents on my side anymore, even my parents. And last 20 seconds of the game, ball comes flying in. My big foot center mid drills it off of, coming in at a full blast. And a girl about this far away took it to her face. Not only was she out for the count, she urinated herself. You want to talk hard hits. I'm just like, ooh. And of course her coach is like, oh, she'll be okay. Littleton Hospital is right there. You might want to take, whew. I tell you what, you go potty in your pants when you get hit in the face. That's a good hit. You what?
Were any teeth knocked out?
No, it looked like all teeth were still there, but boy,
Was she bleeding?
no. She took it. It was actually right on the side of her face. I guarantee this eye is probably swollen up. So anyhow, let's get back on this. Diagram given, right? I can say that angle 6 plus angle 8 is equal to, or congruent to, 90 degrees. Can I say that angle 6 is equal to angle 8? No. Yeah. Oh, extra credit right there. Angle 6 is complementary to angle 8. Or you could say angle 8 is complementary to angle 6. Oh, that's huge. Yep.
So, can you say that angle 6 plus angle 8 equals 90 because the definition of complementary angles? Or would that be
Definition of complementary. Definition of perpendicular, I think you could stretch to. Angle, addition, postulate that leads to definition of complementary. I think that would work. App. Double A-A-P. Yeah, question?
Did you say right angles for that one?
Right angles?
Yeah.
Definition of right angle. I mean, our diagram tells us a lot of good stuff. So don't write off the diagram as not part of the problem. It definitely helps us. Can I move on?
So could the answer be any of those?
Yeah, I mean, that's a whole lot of different thoughts that you can conclude off of this. Which one's right? All. Depends upon what the problem was asked for originally. Now, here's something to think about, though. Let's say, excuse me, let's say this is one of the problems, and it's a 5-step proof. Could you see how this 5-step proof could turn into 15 steps if you started listing everything you could do?
Yeah.
Is it wrong to go that way? No. Okay. It's not wrong to think that way. So, some people want to get from point A to point B. Some people want to go from point A to point B by a whole different sequence of events. Who's right? Both. Yeah, what took longer? Huh. What else can we do? Let's see, this next one, we have angle 1 and angle 2. You got a diagram there, okay. Angle 1 is congruent to angle 2. So I might just put this just so I can see it and feel good about it. But what's something that we could also put? Yeah. Say that one more time.
I'm sorry, AEB is congruent to CED.
Angle AEB is congruent to CEB.
No,
D. Thank you. Come on. Okay, and I'll make that as well. That would work. And that's really just all that is doing, and I agree with you. It's just renaming the angle. There's really not much of a definition to go with off of that, other than you're just using the letters versus the labels. Which way's right? I like it. Yeah, go ahead.
Would it be reflexive then?
Reflexive. Reflexive is normally the same thing as reflexive to itself.
Okay.
What reflexive is going to work on is when you start having this kind of picture. This line right here is the reflexive to itself. Okay? Yeah.
So would the reason be like definition of complementary angles?
No, they're not complementary. We don't have 90 degrees up there. All we did from this step to this step is just renamed. You could say you went off the diagram actually, because the diagram was named. I mean, it's not a real big definition to it, but you could rename it that. Yeah.
Did you say that EB and EC trisect AED?
Ooh, I like your thinking. I don't know if it's going to trisect. It's definitely cutting into 3 parts. I just don't know if this middle part here is going to be the same size at this point. I don't know. Yeah?
Could you say angle AEC
Angle AEC is congruent or equal to angle what? DEB? I like it. Why?
angle
It has to do with angle addition. I agree with you. Go ahead.
Can't you say there are like 2 triangles inside, and then you could say that the middle angle is like reflexive?
The middle is definitely reflexive to itself. I agree. I don't know if we need to say it, but I agree with you on stating that. One thing that I would take a look up here, though, is being we know this and this led to this, there's a number of things that we could do. I'm going to box this in because that's my answer, and I think it's a good go-to. Okay? But some of you might say, well, I'm having a hard time making that work. But let's do this. Angle 1, actually, let me do this. Angle AEB plus angle BEC is congruent or equal to angle BEC plus angle CED. Okay? And that's just angle addition. And then that would then lead you to subtract BEC from both sides. That would then tell you that AEB is equal to CED, which duh. But a lot of that can be stated. So I think, is this a theorem right here? Something to do with, it is angle addition, yeah.
I just have a question. We can assume this is a triangle, right? Because it's not a big difference.
Yeah, the diagram should be correct, showing you a triangle, yeah.
Oh,
So,
okay.
wait.
So could you say that A plus E plus D equals 180?
Yes, you definitely could, okay?
Oh.
But, there's all kinds of things you could say. You could say that this plus this is 180, this plus this 180, this plus this and this is 180. I mean, there's all kinds of 180s you could do. I agree with you. It might not be necessary towards the problem, but you definitely could state it. Now some of you are plotting revenge going, dude, Stirrup's dead. We got 7,000 steps to this proof. And I was, yeah, you're right. You got it.
So our conclusion, our reasoning could be that the diagram.
Not diagram, but there was one that had to do with addition of like angles or something like that. I forget. It's not complementary. Combine like terms. No. Definition of congruence. Two or more angles, symmetric, segments or shapes being equal in measure. No. Definition of point perpendicular. Definition of bisector. Definition of linear pair. Supplementary. Angle addition. Partial angle. Subtraction. No. Angle multiplication. Nope. Definition right angle. Segment addition. Segment multiplication. Segment division postulate. I think this would go along with angle addition property A. So angle 1 is congruent to angle 3. So conclusion C, E, D. This goes with the angle addition property. So this is off the yellow sheet. Top, it says, if an angle is added to congruent angles, then the sums are congruent. Okay? So, being that this right here is obviously, that would mean that this angle here plus this angle here have to be congruent, and it's because of the angle addition property. Because I had two congruent angles, I added the exact same thing to both of those, and that's going to work. Okay? Last one. So they're telling us that this is equal to this. What else can you conclude? Yeah.
AB equals CD.
AB is equal to CD, or you could put that they're congruent. And that is the exact same property that we just said, but it's not using addition, it's using not angle, segment, subtraction. Cool? How do you feel? Better? Better than you had? So what my goal is tomorrow, let's go back to our very first slides that we talked about. There it So, I want to make sure this is done and this are both done for tomorrow. I'll have some time to go over some questions on them, but I want to make sure they're done. This should also give you the opportunity to get a good start on that, which will be due on Monday. Is that all right? Am I saying that right? Tomorrow, I will go over both of those. We'll go over the rest of this, and it's a small, no more than 10-minute lecture on 3.1. Yeah,
When will 3.1 be?
3.1 will be due on Monday. Cool? Does everyone get it?
On Monday?
You what?
Okay, no, I got it.
So, yeah, 3.1 will be due Monday. I don't know about y'all, but I feel a heck of a lot better about myself today than I did yesterday. Cool? Everyone feel good? When's the test? Friday. I moved it to Friday.